All right, here we are for a good, exciting, what morning is it? Okay, yes, it is Thursday morning. All right, here we go. Energy notes. So let's get some energy. Yeah, it may be kind of tough toward the end of the week, but let's give it a shot. All right, so first thing we're going to talk about energy. What is energy? All right, energy is basically the ability to either do work or to cause change. We've talked about that before already. All right. And in chemistry, particularly, we use the ability to cause change. Chemical changes or chemical reactions are kind of what chemistry is all about. In physics, a lot of times it still causes change, but we use it to do work. And so that's why we talk about energy in physics, okay? Now, we're going to talk about types of energy. There are two main categories you've probably heard about before. So a lot of this will be reviewed, but a little bit different. Types of energy is, if it's moving, it is kinetic, that's right. Kinetic energy. And if it's stored or has position where it could fall, it is potential. All right, so that's good. Kinetic and potential. All right, so let's talk about kinetic energy, or KE for short. We can be on an initial basis because we're good friends with kinetic energy. All right, so kinetic energy, the energy that an object has due to its motion, something moving. All right, a car, if it's going down the highway, has kinetic energy. If it's pulled off to the side, it has none. Okay, so if you remember, we're talking about momentum and to have mass times velocity. Kinetic objects are going to have mass, obviously, because everything has mass. And if they're moving, then they're going to have motion or velocity. So kinetic energy is tied very closely to the idea of momentum. All right. Now, so basically, for the kinetic energy, basically, the more the object speeds up, then obviously you're going to increase the kinetic energy. If that car is going at 30 miles an hour, it has a certain amount of kinetic energy and will do a certain amount of damage if it hits something. But if it's going 60 miles an hour, it will have twice as much kinetic energy, right? So it's going to do a lot more damage. So there's a lot more energy involved, and therefore it can cause changes, good, bad, or otherwise, depending on what you hit. All right. Now, it also depends, though, upon the mass of the object, all right? If you have a semi-truck going 60 miles an hour and you have say a Volkswagen Bug going 60 miles an hour, obviously there's going to be a lot more kinetic energy with the semi-truck. So it has to do with how fast and how much mass it has. So the formula for kinetic energy is technically 1/2 times mass times velocity squared. Or another way to write that is mass times velocity squared divided by 2. Okay, it's not like it's half the mass, it's just half of this whole thing, the mass times velocity squared. All right, now, of these two, which is more important then? Is the mass of the object or the velocity? If I double the mass, that's going to make it have twice as much kinetic energy. But if I double the velocity, well, the velocity is squared, so it'd be double, but then it's squared, so it'd be 4 times as much kinetic energy. Okay, so mass and velocity are both important for kinetic energy, but of the two, velocity is much more important. Why? Or not, is going to make a bigger impact. So because it's all about the speed. After all, kinetic energy is the object's motion, so it makes sense that it would involve the speed more. If it was just mass times velocity, that would simply be momentum. Okay, but velocity is squared and then divided by 2. All right. Now, therefore, I could say a change in velocity is going to affect the kinetic energy a lot more than a change in mass. Okay, if you triple the mass, it would triple the kinetic energy. If you triple the velocity, it would make 9 times as much. If you did 4 times the mass, it would be 4 times as much kinetic energy. But if you did 4 times the velocity, 4 squared is 16, so it would be 16 times. So it's exponentially greater increase if you change the velocity. Okay, all right. Now, since energy is used to do work, guess what units it's going to be measured in? That's right. It's going to be measured in the same units we measure work. So it's going to be in joules, or it could be Newton meters. Okay, but basically it's still going to be joules. Okay, mass times velocity squared. That'd be like kilograms times meters per second, meters squared over seconds squared. Okay, but that's joules. Okay, and so it's still going to be measured in joules. And so the 1 joule is equal to kilogram times meters per second, which is newtons times seconds, or divided by seconds. So that's seconds squared. So anyhow, it's still the same units. kg is mass, meters per second is velocity, but if you square it, that means it's going to be meters squared over seconds squared, and it's still the same units that we used when we were talking about power. Okay, I mean, my brain is kind of going kaput here, not work, but power. Okay, so okay, sorry. Okay, I'll get this together in a minute. All right, so that is the formula for energy. Now, we're going to talk about some other types of energy here, but technically, the next few we're going to talk about are really types of kinetic energy. All right. If you heat up a molecule, say you have ice. And ice is a solid. The molecules are locked closely together. If you heat them up, they start to move faster. As they vibrate faster, eventually they get enough energy that they break loose and they start sliding around each other. And now you have a liquid, okay? Because when you heat it, you're changing how fast the molecules are vibrating or moving, okay? And we'll talk about temperature later. Temperature is just the average motion or kinetic energy of the molecules. So since we're talking about how fast the molecules are moving, thermal energy is really a type of kinetic energy. It's just the kinetic energy of the molecules or the atoms in something. How fast are they moving? Okay, and as they move faster, then they're going to have more thermal energy. As we add thermal energy, they're going to get more and more kinetic energy of the molecules. So thermal energy or heat is basically a type of kinetic energy. All right. So as the heat increases, the motion of the molecules increases. All right. As the heat decreases, the amount of heat energy decreases, the molecules get slower and slower. Okay. In fact, we'll talk about this later. But the slowest or the lowest heat you could have is where the molecules don't move anymore. Okay. And that would be what we call absolute zero. All right. Now, sound energy, like when I'm talking to you right now, or actually it's coming out of your speaker, but is vibrations moving through the air. Boom, boom, boom. They're vibrating and they're passing those vibrations to the next molecule until it goes through your ear and it hits on the molecules in there, hits your eardrum, and hits some bones there and stuff, the bones, and transfers it to some fluid. And then it sends that message to your brain, and amazingly, we can take all those vibrations and hear them as sound, okay? And so sound energy is movement or vibrating molecules that are carrying the sound energy to your ears. And so, and yes, technically, even if a tree falls in the wood and no one's there, it's still sending those vibrations, even if nobody is there to pick them up. So yes, a falling tree in the woods, if no one's there, does make a sound, although you won't be there to hear it. Now, the sound of one hand clapping, well, that's a different thing. All right, anyhow, sound energy. So sound energy is kinetic or vibrations or movement of molecules that are vibrating. All right. Electric energy or electricity, okay, is another type of energy. And it is really the flow of electrons, okay? And since it's flow of electrons, then it is technically a kinetic energy because you're actually saying the electrons moving from one atom to another. And so it's the energy being carried down the line. So that's still a form of kinetic energy. All right. So electrical energy is just the flow of electrons. Once again, it's kinetic energy or things that are moving. Okay. So once again, it's a type of kinetic energy. All right. Now, the other type of energy is potential. Potential energy is energy that is stored and has the potential then to be released. All right. Normally, when we think about potential energy, we're talking about energy that is up in the air and has the potential to fall. That's a lot of times what we talk about. Okay, when we give an example of this, especially in lower grades. Technically, this is not the only kind of potential energy there is. This is gravitational potential energy, okay? In other words, gravity gives the object the potential to fall and have kinetic energy. So we are saying that this is gravitational potential energy. All right, so it's objects that are above the Earth's surface and therefore have the potential to fall down to the Earth's surface. All right, so let's stop for just a second. Let me set up a example and we will be right back. Okay, all right. Okay, so here we go. We have a weight right here. We have a string right there. This is the pendulum. When I have it up here, it has what kind of energy? Potential. All right, it has potential. Once I drop it, it begins to move. What kind of energy does it have then? Kinetic. All right. So when it's up here, it has mostly potential. As it comes down here, it has mostly kinetic. So the worst place to be hit by it is
right there.
Down here at the bottom, because it's all kinetic and it hurt. All right, it comes back up. As it goes up that side, it changes to potential, and then it comes back and changes to kinetic. Back and forth, back and forth.
Didn't you tell us
back and
before?
forth. Yeah,
I'm pretty sure.
All right, if you hit the pause button there.
Oh, there's a video going.
That's right, y'all are.
Wait. What's this
I'm on video.
pause for?
Oh, hit the little button.
Yeah.
There you go. All right, now hit the pause button. All right, and we will finish up the rest of the notes tomorrow. Have a great morning.